Okay. The basic mechanics, as you can tell, my wonderful chalk is improving my handwriting today. The basic mechanics of forge welding are this. Create a clean surface to allow for pressure to bond the two naked surfaces of the material to be welded together. Did that make any sense at all? Probably not. But by adding heat, so cleanliness in preparation, so you can clean that thing up, you can soak it in diesel, and there's a whole lot of folks in the knife making world that are doing some really, really incredible things with forge welding and zero flux forge welding and all that universe. Go have a look at Mareka Malmasi, all the Dragon's Breath guys. I'm trying to think who else. There's a bunch of them. But very, very interesting canister formation, so on and so on and so on. There are some basic principles though that you have to abide by. First of all, you've got to get it up to temperature in order for the material to be able to bond, and apply an appropriate quantity of force in that bonding zone in order to create that bond, as long as it is clean. And what you've also got to think about within this universe, explosive welding is actually part of this same thing. So cladding, pretty kooky stuff, but same principle. But as a blacksmith, as human, we have the ability to bring our material up to temperature, allow for those oxides and silicates that are on the surface to slide out of the way. Essentially, they become liquid and then migrate. And then with pressure, you want to close your joint. So if you have a joint, like a huge joint where it comes around, you're just gonna have to bear with me like this. So this is my U joint, this is a single piece that's coming around like that. If you start closing from here through into the bottom of your joint, you might get slag entrapment in the closing here. So be careful of that, be aware of that. Likewise, if your material is cupped like this, right, on a lengthwise, and you get it to weld on the outside, you've got all that slag and silicates and flux and Lord knows what else on the inside that are going to have problems exiting. So if you're doing an exceedingly wide weld, so say 3, 4, 5 inches wide, I would recommend running from one end to the other, down the center line, and then working outwards in order to get that weld to start on center and go outwards. Also, we have an issue with the material at this point, that it is very, very pliable. And because it's very pliable, it's going to move a lot. So when you're trying to create that weld, if you hit it too hard, you can actually cause the material, as it compresses to create the joint, it will then shear, right? So in other words, don't whack it too hard, don't whack it hard enough. As I said in the Instagram intro one, and by the way, I apologize for writing card zone instead of carb zone. The joys of dyslexia are strong today. Where was I going with that conversation, Jess? Oh, Elmer. Elmer uses a very light hammer in order to get that weld to happen. You don't have to hit it hard. Okay, so I'm going to do my weld prep right now. And I'm just going to do this as a little fold over, essentially a lap weld or a scarf type weld. I don't want to try and jiggle 2, 3, 4 pieces of material on video, thank you. I don't want to get this too thin, otherwise it's going to give me problems. But likewise, I don't want it too fat, otherwise that will actually create a vertical shear. So what I've done is I've made a elongated joint so that this here doesn't close down and create a sheared shoulder. You see how my fingertips kind of create a sheared shoulder? That then makes a weakness in the weld. From there, I am going to fold it. Also, I brought that material into the same thickness. Give it a little bit of a bend. And, you know, this would be essentially the same way that you'd make a pintle hinge or a ring or something like that. Shall I do? No, I'm just going to fold it well. Maybe I'll do that later. And I can actually prep the material here also where that lip is. I can create a notch. There's so many really interesting joints that you can create in this kind of construct.
Before you put that in the fire, will
yeah.
you set it down real quick? So I just want to point out, so right there at that joint is where he's going to have to start closing it so that everything can go squeeze out that way and out the sides.
Yes.
That's what he was talking about earlier, trying to show you with his arms.
Yeah, which probably made no sense at all. So instead of getting really crazy about it, I'm just going to put that front end of that seam into the forge to really bring that up to temperature. And I'll weld that up first, and then I'll creep up the line into that area. And you know what? I'll put a glove on because I will be welding towards me. I'm not going to flux this one. But it really can squirt a lot of rather molten nastiness onto your flesh, and virtually every single time it winds up in that little crook in your hand. You know, and if you're doing a lot of forge welding, you're going to look a right mess. You wind up with toad skin because you've got little blisters all over yourself. I've had welds blow out, especially if you're doing them under the power hammer. Have them squirt everything out and they just hit you in a big line across the body. Jessica's actually put her leather apron on, she's sensible. So I'm bringing this up nice and slow. I'm moving from the side, so I'm doing side, side, back. I'm not worried too much about that top position. And the first thing I'm going to do, even before I try and close the weld up, is I'm just going to seat everything. I don't want to be trying to move a whole lot of material or even leave a gap like this where a piece of coal could get in. I've had that happen before. So it's actually really close to forge welding temp there. So close that up, I'm going to get that little nipple out the way. I'm actually right on the edge of forge welding right there already. It actually started to happen.
Yeah, it's hard to see in the video. It's so bright.
Yeah.
But
I'll give it a little brush out. And we'll go for another. So if you were doing, say, a ram's head, right, like this one, and you wanted to forge weld it in here, this is basically what you'd do. You just forge weld up that front portion. And it's a really easy little weld. It's just, you know, you close it up, prep everything, you bring it up nice and slowly, and then, boop, it happens. This is why forging presses work so well. Because forging presses go, a little tiny bit of compression, you can set your compression, you know, like 1/4 inch, something like that, and it will weld up beautifully. I don't know if you can see into the fire here, Jess, with the camera. I can just about see my material there. It's really coming up very nicely.
Yeah, it's hard to see.
Yeah, you probably just got a giant glowing orb of nothingness.
Do you want to talk about what color it is that you're looking for in there?
Well, it's more a appearance of the surface of the material. First of all, it's white. It's well into that bright yellow-white range. And then you just look for the surface of the material to start to become wet. I know that's weird, but that's actually the liquid silicate starting to happen. I've got a little bit of sparkling that tells me that I'm definitely up to temperature, but not too much. All right, lift it out, there we go. Nice and gentle. I'm just going to do that portion. Give it a quick rub so you can see it hopefully a little better. Then There we go.
So it's hard to see what it's so
Yeah,
bright.
I'll try and point, but you can see that seam of oxide through here to about there, and then out of here I didn't bother going in on the weld. And the other side actually welded even better. Don't know why, I'm probably hammering ever so slightly centric to my left side. But when you do the weld, here's a little thought for you. If you only hit it from one side, so say I only hit it from here, I'm getting more deformation on the top side than the bottom side. Plus, the bottom side is cooling. So if I'm gonna go for a second heat, which I am, I'm gonna give it one more brush. And this time when I come out, I'm gonna work it from this side. And, you know, I've always been a little bit of a belt and braces type person. And I've found, for me, and maybe this is just my paranoia from when I was really starting to forge weld compared to now, I always did 3 cycles. So I did 3 run-throughs at forge welding heat. And then once you start forging on it, you actually want to keep it very high in temperature. So just on that verge of forge welding, so that you're actually not overstressing the seam. You're actually essentially asserting the seam. And when I'm doing billeting, I always do a triple fold. So I cut it twice and fold it 3 times, which means that my centerpiece, my original chunk right in the middle, was my very, very first weld. So if my first weld is good, and it has been continuously asserted with every fold that I've done, it should be the strongest and most assured weld within the stack. If that makes any sense. If you only do a double fold or you do a 4 fold, it means that your center seam is always the very last weld that you did. So again, just bringing this up nice and slowly, I'm sticking a little deeper in the fire to draw the heat back into that scarf area. So I'm doing bottom, left, right. And this just goes to show you can forge weld pretty big stuff. I would probably do, I don't know, 1 inch in here fairly happily with a relatively small forge and really not awesome coal. I mean, this isn't horrible coal, it's actually heating coal. As I said earlier, from probably at least 50 years ago. But it works great. A little bit of sparkling in the fire, that's fine. And out we come. Rolling back into that scarf. Alright, my scarf got out of alignment, so I'm going to push that. A little scrub. And that forge welded in pretty well, except for that little bit of jiggery pokery at the back here. But I did get that at appropriate temperature. Before that gets too cold though, I want to get it back into the fire because I do have that thermal mass nicely in the body of the material. And that is a benefit of this, you know, you've got to kind of keep rolling. You don't want to allow the material to come off the bubble because you spent all that effort getting the core up to temperature. So keep it at temperature. Keep your work movement short. I've even seen folks actually, if they're doing like scarf joints or jump welds or butt joints, actually do them in the half. Because why not? It means you can literally do it while still being heated by the fire, still in a low oxygen environment. Also notice I don't need a gigantic raging fire to do this. That thing's probably 6, 7 inches across. I think I'm about temperature. I'm getting that little bit of fine sparkling. Should be good. Oh, that's a little hotter than I wanted. Kind of broke the back end of that weld again.
Oh well.
Oh well, you get the principle of it. I kept overworking in this little zone here, and these are always like funky little bits, but that welded in pretty well. You did see that there was a little bit of material loss. That is the nature of it. There is a touch of wasting at the back of my seam here, and in order to avoid that, I'll actually get into the discussion about it, but in order to avoid that, you can actually upset the material or push the material, backwards in order to build a pocket so that when you do the forge weld, you don't get reduction in joint. And you know, those are just some little things to be aware of. So that's forge welding, give or take. Big one, when you get to here, don't throw it in your bucket of water. You will blow that seam. So allow it to cool off naturally and you should be far better off. Okay, maybe my next one I'll do with some flux.